The skid resistance test is a crucial procedure used in road construction and maintenance to evaluate the ability of a road surface to provide adequate friction and prevent vehicles from skidding. It is essential for ensuring safety, particularly in wet conditions. Here's an overview of the test. Purpose of the test: to assess the frictional properties of the pavement, to determine if the surface provides sufficient grip for vehicle tires under various conditions, to identify and mitigate the risk of accidents caused by skidding. Methods of testing. Several methods can be used to measure skid resistance, depending on the equipment and standards. 1. British Pendulum Test, BPT. A portable device measures the frictional resistance of a road surface. A pendulum arm with a rubber slider is released, and the energy loss caused by friction is measured. Results are reported as a pendulum test value, PTV. 2. Sand Patch Test. Measures the macrotexture of the road surface. Sand or glass beads are spread into a circular patch, and the volume is related to the road's surface texture. 3. Sideway Force Coefficient Routine Investigation Machine, SCRIM. A specialized vehicle equipped with a measuring wheel at an angle to the direction of travel. Measures the sideway force coefficient to evaluate skid resistance over long stretches. 4. Dynamic Friction Tester, DFT. A rotating disc with rubber pads measures friction at varying speeds. Provides detailed data on the frictional properties. 5. Locked Wheel Skid Tester. A test vehicle locks a wheel on the surface, and sensors measure the frictional force. Often used to evaluate runways or highways. Factors affecting skid resistance. 1. Surface texture. Macrotexture. Large-scale roughness, and microtexture, fine roughness, of the pavement surface. 2. Material composition. Aggregate type and quality significantly influence skid resistance. 3. Weather conditions. Wet or icy roads reduce friction. 4. Traffic volume. Polishing of aggregates due to repeated tire action. Importance of skid resistance testing. Reduces the risk of accidents caused by loss of control. Helps prioritize maintenance on sections with low friction. Ensures compliance with safety standards. Improves road performance during wet weather conditions. Here is the detailed procedure for some commonly used skid resistance testing methods. 1. British Pendulum Test, BPT. This test is widely used for measuring surface friction in both lab and field conditions. Equipment: British pendulum tester with a rubber slider. Cleaning equipment, e.g., cloth and water. Procedure: 1. Prepare the surface. Ensure the test area is clean and free of loose debris or moisture. If the surface is dusty or wet, clean it thoroughly and let it dry. 2. Position the pendulum. Place the pendulum tester on a flat, stable surface. Ensure the base is level to avoid errors. 3. Adjust the device. Set the pendulum arm to its starting position. The rubber slider should be in contact with the road surface during the swing. 4. Conduct the test. Release the pendulum, allowing it to swing over the test surface. The slider moves across the surface, and friction reduces its energy. Record the energy loss shown on the scale, representing the pendulum test value, PTV. 5. Repeat. Perform the test at least 3 times at the same location. Calculate the average PTV for consistency. Interpretation of results. Higher PTV values indicate better skid resistance. Typical values: less than 25, very slippery. 25 to 35, adequate for low-speed roads. Greater than 55, excellent for high-speed roads. 2. Sand Patch Test for texture depth measurement. Equipment: sand or glass beads. A measuring cylinder and straight edge. Procedure: 1. Clean the surface. Remove all dirt and loose materials. 2. Spread the sand. Pour a measured volume of sand, usually 50 milliliters, onto the surface. Use a circular motion to spread it into a uniform circle with the straight edge. 3. Measure the circle. Measure the diameter of the sand circle in multiple directions. Calculate the average diameter. 4. Calculate texture depth. Use the formula \text mean texture depth, MTD, equals \frac, \text volume of sand, /text area of circle. Interpretation. Higher MTD values indicate better macro texture, essential for drainage and wet skid resistance. 3. SCRIM, Sideway Force Coefficient Routine Investigation Machine.
Equipment.
A specialized vehicle with an angled test wheel. Procedure. 1. Prepare the equipment. Calibrate the SCRIM device before testing. Ensure the test wheel's rubber is in good condition. 2. Conduct the test. Drive the SCRIM vehicle over the test road at a specified speed. The angled test wheel applies a side force to simulate lateral skidding. 3. Collect data. Measure the sideway force coefficient at regular intervals. Results are recorded digitally for analysis. Interpretation. A sideway force coefficient SFC of 0.5 or higher is generally considered safe. 4. Dynamic friction tester DFT. Equipment. Rotating disc with rubber pads. Procedure. 1. Position the tester. Place the DFT on the surface to be tested. Ensure it is firmly secured and level. 2. Apply water. Wet the test surface to simulate wet conditions. 3. Start the test. Rotate the disc at varying speeds, e.g., 20, 40, and 60 km per hour. Measure the frictional force at each speed. 4. Record results. Collect data for each speed. Analyze the variation in friction with speed. Interpretation. A steep drop in friction at higher speeds indicates poor skid resistance. Conclusion. Each method is suited for specific applications, from spot checks to comprehensive surveys. If you need help selecting a method or interpreting results for a specific project,